So.
Hello.
Well, I guess we just leave them in the box and just get put them over in the serum room. Because it has people.
Senator Blumenthal say might does not make right.
How many people? 7, no, 7, 8. Hello, class. How y'all doing? All right. Okay. Anybody with any questions? Anybody been working on my programs?
I haven't. I've been we recently lost like 3 people at my work, which is already understaffed, so I've been working exponentially more.
Right.
Yesterday and today were the first days that I had off in a while.
Break. Right.
Yeah.
Okay. All right. When them programs was due? When I made them due?
You made them due last night. Yeah.
Last night. Okay. I might open them up for a few more days so y'all have time, because I know the storm came through also. You know what I'm saying? So I could do that. Give y'all a couple of more days.
If you could do that, that would really help me out.
All right. Anybody else have any other kind of concerns or whatever about the assignment? Like I said, it's best you take your time and do it, in stages. Look at. Excuse me? Somebody said something.
I think that was just background.
Okay.
Can I talk to you after this, by the way, about the Linux class?
All right. Okay.
Cool.
All right.
Thank you.
Okay. Then, like I say, you look at the notes, look at the videos, and like I say, the programs that we do is not exactly, but it's in the same concept of what we're doing, so it can kind of guide you into completing your assignment. Turn this thing off. Cut this thing off.
Okay.
All right. Here we go. So let's get to the notes. So we were in what chapters? We had gotten to chapter 3, right? Well, not 3, 9, right? With pointers. Let me see. No, not this one. No, not this one. Not this one. Let me see something. All right. 194. Okay, the second one. Okay. Oh yeah. So yeah, we need to just complete the second chapter. The little bit of notes we have on the second chapter. I'm gonna repost the assignments. I'll give you 2 more days to do that. Today is the 15th and the 16th. I'll do that on those assignments, programs 3 and 4. All right. Now, also on the documentation class, any issues, questions about that on my documentation? Because the documentation should be gimme points, and I'm gonna just do the until date. So you're gonna see the due date, but I'll do it until date, and it'll still be open.
I do have a question on the page where you want us to describe what the program does. Do you want like a full page of just BS, or do you want just like what it does?
No, I want exactly what I give you to do.
Mm-hmm.
Yeah.
Well, no, I bring this up because you were talking about before how like if you say one page of something, you mean like a whole page. I just
Oh
want.
no, I said on the next page, I said a new page. You know what I'm saying? It just start
Oh,
right. Just like with
okay.
your document, I mean your source code. Your source code might run 3 or 4
Yeah.
pages. You know what I'm saying? But you're gonna start it on a new page, like a new
Okay.
section. Because what happens, I don't want to have it all jumbled up, and now I got to figure out where it starts, where it stops, where the next one. So if you just start them each on a new page, I know, okay, I'm finished with this one. The next one will start on a new page, and I can run through it. Okay, the next section, new page. You got me?
Yeah. I just wanted
Yeah.
to
So
make
it
sure
can
I
be
wasn't.
it'll be 5 pages,
Yeah.
but you gotta understand. Give me exactly what I give you. Like if I
Mhm.
have a PDF saying do whatever, showing you the layout of the output, telling you, got a diagram saying, okay, this variable, this is the array, this is an array, this is this is the how I want the naming scheme, whatever. All that should be in there.
Okay. I'm just making
Yeah.
sure I'm not like putting too little into
Yeah,
your thing.
sometimes and most people do. I want to see the exact same instructions that I gave you. So
Yeah.
that way, it's like when somebody else get that paperwork, they see the exact same thing you saw. It's
Yeah.
not say, oh, something was missing, oh, it's not described the same, whatever. It's the exact same thing.
Okay.
All right.
Yes,
Yeah.
sir.
All right. Let me change this one. Okay, that's done. So that's assignment 3 changed to the 16th. The next one is assignment 4 changed to the 16th. And then the document. And what I did, I eventually, and it's not anything pretty. It just it got cover page. And what I did a hard return to say, okay, go to the next page. Then I got the statement of the problem, hard return, and then the next one, the source code, hard return. So I kind of give you that document. You could probably try to take that document and do your hard returns at the end, or if it's already there, you're straight. Or you could just create your own and do the control enter. The control enter is a hard return key combination in Word that automatically creates a page break wherever you are on that page in that document. So automatically the printer knows, the system knows that, okay, from this point on, I'm gonna go to a new page. All right. And I could show you that let me go back to Zoom. All right. So let me share my screen. All right. So in Word, say this is a Word document. What I did. Okay. All right. So if I have this information in here, or this is some of what I turn it. Like if I wanted a control enter here, I'm in this on a new page. Hold the control key, hit enter. It automatically brings it to a new page. Click here, hold the control key, hit enter. Automatically brings it, see, from here to a new page. And whatever I'm gonna have in here, if I have other information, it'll just keep going down and allow me to have a new page, and my other information still starts at a new page. So control enter creates the new page. All right. And that will keep all your information on wherever you want it to start on a new page. So like I say, you can do it that way, create your own document and just use the control enter, or like I say, follow that guideline. All right. Let's get back to the notes. All right. So here in the notes in chapter 8, well, no, this is 194, not 193, because this is the actual book notes. I can do it here. All right. So, yeah, we went over the algorithms of the search, our search algorithms. We went over our sort algorithms. And if you saw in the instructions, you're going to have a search algorithm and a sort algorithm in one, and then a search algorithm and a sort algorithm in the other. And class, I want each one of those processes to get the retrieval of the data, the printing of the data, the sorting of the data, and the searching of the data. And I said printing already, all in functions, all right? You're going to group your data in your program in functions, all right? And like I say, this was the actual code for this sort, all right, that you can compare, look at, whatever. But remember, when you're sorting, when you're searching, you can only search, all you need to do is search for one array value. You don't have to search for a name and amount. We just doing the search on the year. It's kind of like when they do a search for your ID. They don't search for your ID number, your name, and your address. They search for the ID, and then based on the ID, whatever subscripts associated with that particular ID, when it's in a table or whatnot, they'll just match them all and bring up all your records based on that. So that's basically what you're doing in here, all right? But if you're sorting it, you have to grab all of the different arrays, and when I change or change the position of the year, I have to change the position of the name and the amount. Okay, otherwise your data gonna be scrambled. All right, so then we talked about the selection sort. Okay, so we went through those. So let's look at vectors. We kind of touched upon vectors in chapter 7, but we did a little small program, which was okay, but and we're kind of touching upon it again. Okay, vectors. All right. Vector initialization. Okay, when writing a C++ program, you must remember vectors do not accept initialization lists. All right. In order to input values into the vector, values into the vector, you must use the pushback member function. All right. So what happens is, if you look here, you're saying that value, which is a variable of int, is equal to 912. Okay, and we can start at 912, so it's equal to 912, and you're gonna run this loop from 912 through until it's less than or equal to 922, and each time we go through, we're gonna increment our value for val. All right, our value of variable. So what happens is ID would be the vector, all right? And that vector would be of what data type? Would be int, right? So that int vector, all right, you would do the vector name dot pushback, which is the member function, and inside these braces would be that variable name, so that what happens each time you go through this loop, the first time is going to be 912, add it to the first element if you're at the first position. Then because a vector you can add on, remember? You could create a vector of 10, but then if you do a pushback, it's going to give you the 11th element, 12, 13, whatever. But if you just create a null vector, the first pushback would be the 0 element. So you got to kind of keep that in mind, because what could happen is you create a vector of 1,000, and then you start doing a pushback, but then you try to read the first 10 or first 20 elements in that vector, and you're coming up with nothing. That's because nothing was placed in those first 1,000 elements. Everything start at the 1001 position of the vector. So keep that in mind. So here we got ID dot pushback, and the first value will be 912. It goes through increment plus. The next value will be 913. 914, 915, 916, 917, 918, 919, 920, 921, 922. Oh, 23 kicks out. All right, so all those values would be placed in ID. So ID would be a vector from size, whatever 912 to 922 would be as like 20, right? Or 10, my fault. I think it's like 10 or 11, really, because you're starting from 2 and ending at 2. All right, so now it tells you you really can't initialize a vector, but you can give it a value. You know, units would be a vector, possibly of int, and you got unit dot pushback, and you're giving it a actual value. Unit dot pushback, giving it a value. So that's the only way you can pretty much create a vector and give it, you know, these values. But in writing code, you may not want to write it this way. Nothing wrong with doing it this way if these are concrete values that you know you're going to use. But at the same time, you can have what? These values being read from a what? A data file. So each time you need to use these particular values, you can actually have these values listed in a data file, read that data file, boom, and they're in. So you don't, you know, have this code listed in your program. All right. But that's how you can do it. All right. The code on the previous page, which is this page, appears repetitious because the pushback memo function is written each time the value is placed in the vector. And that is correct. As opposed to in this one, each time it goes through, you're doing this 10 times, all right, or 11 times, and you got 2 statements. But you're doing this one 1, 2, 3, 4, 5, 6, 7, 8, 9 times. And look how many statements you had to write. Okay. So, so it says this code can be simplified by storing values needing to store into the vector into an array. So that's another way you can do it, but at the same time, you'd be creating an array and then reading the array values into the vector. All right, can do that. If you got an array that's initialized and then you want to take that array and put it in a vector and then use those values in a vector, you can initialize an array. Remember, this would be, okay, const int numprods, and it's 9. So numprods would be your what? Size declarator, all right? So units sold would be your what? Would be your array. And of what data type? Int. Why would you know that unit sold is an array? You got the curly brace here, all right? And then this would be the number or the size of the array. And we got what? 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I've got a question. Would this statement be valid if I only had 2 numbers in here and then the curly brace right after 416? Would that statement be valid? Anybody? Would this statement be valid if I had int unit sold, open square brace, numprods, which would be 9, close it, equals curly brace, 843, comma, 416, close square curly brace, semicolon. Would that be a valid statement? Anybody? Hello, just a yes or no.
Sorry, I just got back. What up?
Okay, given this code here, what we did, we created an array of 9 elements, all right? It's initialized to 9 elements. Okay, the size is 9. Would this statement right here, would this statement be valid if I had this information, int unit sold, open square brace, numprod, which is 9, close it, equal, open curly brace, 843, comma, 416, close curly brace, semicolon. Would that be?
So there would be a bunch of uninitialized elements in the array.
But would it be valid?
Valid?
Correct. You can undersize the initialization, but you can't oversize.
Yeah.
Correct. So everybody and I'm trying to get you to understand it, because many times what a programmer may do, if they writing code and they using arrays and they dealing with say students, and like say students at BRCC, and you happen to have to write this code, and they say they want it in arrays for whatever reason. So all of a sudden now you're gonna have to determine what an array size for the total number of students that's going to be stored into that array, correct? So what you would do, you would kind of do an educated guess saying that, okay, and you might work with even the admissions department. What is your maybe minimum number of students enrolled? And what is your maximum number of students enrolled? Or you might just ask, what's the maximum number of students enrolled over the last 10 years? So you can look at a trend. If it's steady rising, you might want to bump it up. Like say if they got 8,000, and then like I said, it's rising 1,000 every year. Then you say, okay, in 2 years it probably go from 8,000 to 10,000. So what? I have to increase my my array size from like I might not use 10,000, I might use 20,000. You understand what I'm saying? Well, I have enough leeway, in creating and putting data in without having any kind of violations on my array, right? So those are some of the things you got to consider at times. But we writing small programs. Many times we know the size, or we read from a file and we get that size and we deal with it and we finish with it. All right. So that wouldn't be an error, but it's just that we'd have only 2 elements in the array and the others would be set to 0. All right. But it would be valid. Now, so we have 9, and what we're doing is we're showing you how you can, not in a sense, they call it initializing, but actually what you're doing, you're taking an array, initializing an array, and then dumping it into a vector, all right? In a sense, creating a vector of whatever size with whatever values. So what happens is we initialize our array to be of 9, all right? And then our 9 elements, our 9 values. And then look, this for loop gonna go from 0 to what? Less than the 9, because 0 to 9 or 0 to 8 is 9. So for counting 0, count less than num prod, which is 9, count plus plus. So units dot pushback, units would be an integer array, and we're gonna add to the first element, all right? We're gonna add to the first element unit so sub count, so sub 0. Unit so sub 0 is 843. So in the first pushback, unit's gonna equal to gonna assign the position for unit at the 0 position to 843. And then the second position 416, the next position 112, the next position 514. So all you're doing is initializing an array and then dumping that array into that vector using that pushback. All right. So that's the way you can do it, to actually move those values into a vector. All right. Because many times, like I said, a vector cannot be given an initialized list. Now, this portion deals with using and passing vectors to your different functions, all right? You passing vectors to different functions, all right? So like say when we're dealing with functions, all right? So if I want to pass a vector to a function, just like when we did I would say not array, let's say string. When we had a string variable that we had to pass, we would do string and then the variable, and then that's it. All right. But if we was passing it by reference, we use the ampersand. But we look here, when I'm passing that vector, I have to pass that vector address. So I do vector, the data type, and then the ampersand. So that what? No matter whatever I do to that vector when I in that call function, it's going to be done when I return back to the main or the calling function. So here, another one, vector int and ampersand. So that means I have one int vector, two int vectors, and then the third one would be a double vector, okay? Now, that's the prototype, right? But now when I call the information, looking at this list, this would be in the function that I'm actually trying to call int vector. I'm passing the what? An integer vector called what? ID. I'm passing an integer vector called units, and I'm passing a double vector that has been declared that we call price. All right, everybody see that, right?
Yes, sir.
All right, now I don't have it on here, but in the function header, you would have void int vector, well, init, my fault, init vector, and then you would have vector int, and then what? Ampersand, and then the name of the vector that you're going to be using in that function. You got what I'm saying? You're going to pass ID maybe into vector int, init v ID. You know, just giving it a different name, but you don't have to. All right, you're going to pass units into vector int ampersand, and then you would give it a name init v unit, and then you'll pass the vector price, which is double prices vector. It'll vector double, and then ampersand, and it could be init v prices. And then whatever you do in that function gonna be those variable names you define in that function header, right? Those different variables. All right. So anybody got any questions? All right. Anybody are having issues with the program, understanding what's going on with their program, having issues not reading in the data properly or whatnot? I did grade my previous class assignments. And I don't know if did I grade? No, I didn't grade you all's assignments yet. What happens is, if let me see if I could pick out some issues that some of them had. One issue was in was it this one? Let's see, which one of those? I think it was the binary. All right, so let's look at this binary search. If we look at this. This says. And I had 2 or 3 people mess this statement up. They had while found and first less than or equal to last. What is wrong with that when I say that? While found and first not equal to last. How did that statement read?
It would read as false and first, because you don't have the not in front of it.
Correct. You see what I'm saying? So without that not, I'm changing the logic of my program totally. You got what I'm saying? So what they did, they forgot to put the not in their while statement, which threw their logic off altogether. Everybody understand that? So you got to be wise to this. Let me give you another example. Some students, what they did all this. They got all their initializations correct, all this. They got even the whole program correct, but they could never get the search value or the record printed. They could never get it. Always say record not found. Always say record not found. No. My fault. It always said give them the first record. No matter if the record was found or not, it would give them the first record. Now, this is what they did. Wrote the whole code. And at the very end, before this curly brace, they put return 0. Now, I know what they was doing, being that they always wrote the main program and put what? Return 0. it might have been an automatic thing in their mind to say, oh, return 0. So what happens is when they put return 0 here, what position are they returning of their search?
It would be to 1.
No, it'd be
Well,
that
it would be
first,
within the array. Yeah.
yeah, which is the first record.
Yeah.
So whether you found the 5th element or whether you did not find any, you always told it to print what? That you found the what? The first one, right? So like I say, don't put return 0 here. This would be return whatever that position is. And if it's not found, it would state a -1. And if it's found, it would be assigned to whatever location. Okay, so and all I'm saying, make sure you check your code. Make sure you go through it and look at it that you're doing it correctly, because this can cause a lot of headaches. And you know you're writing it, you know you're not getting any syntax errors, but you're not getting the proper output. Okay, so that's some of the things that went on. Make sure you're doing the proper swaps. All right, when you're doing your swaps. Well, this is the search, so you're not really swapping anything here. So the search doesn't do any swapping; it's just searching for the value. All right. Now, like I say, make sure you're reading your data file, and like I say, you got a string array, you have an int array, and you have a double array. So everybody should know how to set up the data file. To set up the data file, like I say, if you're in Visual Studio, like I say, all you need to do is, if I can pull it up. All right, in Visual Studio, so okay, this is a program that student was working on. But if you're in Visual Studio and you need to create a data file, remember, all you need to do is you go to source, or you could go to header files. Either one take you to the same place. Add, new item, okay? And now you want to choose utility and choose a text file, okay? And then give it a name, whatever name you're going to use it. And I can say, anything. I could say data.txt, but I don't know if I think I gave you a specific naming scheme to give it. Okay. Now, all of a sudden, this is my data file. Now, in the data file, all I need to do is put in a name. All right. Name, year, amount. Name, year, amount. Name, year, amount. I told you to process 10 records. So you would put 10 name, year, amount. All right. Name, an amount. Now, and even if I put this, it's going to take this, and if it's float, it's going to add the 00. But remember, when it pulls this in the program, in order for you to print out 182.00, you have to use that what library? That IOMAN IP library, so you can do the what? Set precision, fix, set precision 2. So you have the what? 2 decimal places. All right. So that would be valid, because it'll look at this as a number, it'll pull it in, and then like I say, whatever other well, let's see. And then so like I say, all these you have 10 records. Now, if you have more than 10 records, the only issue you'd have is if I said read while end of file, if I had 20 records, it'll read all 20. If I had a loop that say go from 0 to 10, then it'll just read the 10. But if I just put 10, it'll read, 10. All right. So those are some of the things you'll learn as you work with files, because many times you don't know the size of the file. I'll give you an example. A company might have people who've applied for credit cards. how many people have applied? You don't really know, but you got the information in some type of list or text file. So rather than you try to count all these names to see how many in the list, all you can do is what? Actually have them read the data file until what? It get to the end of the file and you have your number, and then it performs whatever it needs to perform. Now, if you're putting that stuff, information, into an array, we're going to have to, again, kind of guess or guesstimate how large that size is. Because with arrays, what happens, once you get to the limit, once your program starts running and you say you only have 20 elements in that array, anything beyond that, you're going to have you're going to have conflicts, all right? You're outside the boundary of the array, and you're going to have errors in your program, all right? Okay, but like I say, then when it'll read that information. And what happens? How does the system read data? All right. I had some people in the previous class. What they did, they read the entire line. I don't want that. I don't want you to do a get line. I want you to read the name, the year, the amount. And what happens? The system reads going across, just like we read a book. All right. So it's going to read up until this. If you read line, get line, it's going to read the whole line. Obviously, it'll read the whole line. But if you just getting a particular string, it's going to grab up until the blank. You're grabbing a number with the int, it's going to grab from here till the blank. And then grab this number of the float here until the blank. All right. Now, you might say, well, Mr. Vessa, what if I have something like this in my program? What will happen to my data and the way it reads it? Nothing's going to happen. What happens is the system will read up until a blank and take that information. Then it will read again, but they're going to take from here up until the blank if it's int, all right? And then it's going to be read from here up until the blank. So it won't cause any issues to your program if the data is spaced out, because those white spaces are not counted, in that input. Now, if you have a fixed size, and that's going into the advanced side, you say, okay, from this column to this column, I'm reading in whatever. Then from this column to this column, then it would consider those spaces as part of the data or whatnot. Okay, but we're not dealing with fixed data sizes or column widths or whatnot to read the data. All right. Anybody with any questions? Questions?
Yes, sir.
All right. So what I'm gonna do, I'm gonna go to here. I'll go here and I'll post a test so you know that it's posted. And what's the date of next week? I'll post it up until the 21st. All right. I go to modules. All right. So that would be, and I'll post the quiz, the reading. Well, I'll give it the reading. Okay. And that's just bonus. Okay, reading. Okay. Save and publish. Okay. Back to modules. The quiz is like about 10 questions from the chapter reading. Quiz. Okay. Okay. Like this. All right, and then I'll do the test. And everybody can take the test and whatnot, right? The proctorio is working for them. working for you, hopefully.
The last one we took, it forced me to take my glasses off.
What?
Yeah,
And you need the
because the
glasses to
glare,
read. Yeah, you need
because so my face is really up close to the screen and
right.
the camera, but yeah, because the glare, it was too much. And it was just this
Wow.
class, because my biology class lets me do it, but yours specifically was like, nah, you gotta take them off. I was like, all right.
And I didn't set nothing. I didn't really set nothing specific in it.
Huh. Okay.
Yeah. I don't know why is that. Because I just added it and just like I'm doing now, and that was it. Okay, so let me go back. I wonder
I
what.
get the reasoning, but like some people aren't even nearsighted like me, so they would have to be
Right, but
like
that was. But I don't even.
like far away
Yeah.
from the yeah.
Right, but I don't even get the reasoning because, like I say, if you need your glasses, like I say, to read, like I
Yeah,
say,
my
they
thing
can.
is the glare, right? They don't want you cheating. So it's like I get that much, but I need them, you know?
Right, but I'm saying I don't even get. Like I say, I don't get that because to most computers have security where you can, like say the face recognition,
Hmm.
and they do it with the glasses. So I'm like,
I
man, if
guess yeah,
you're
you
gonna
would
be that if you're gonna be that sophisticated, I don't
mhm.
know. I don't know what's what.
I guess if
Yeah,
you're gonna be cheating too, you would turn your head as well. I
right,
don't know.
right. So I don't get that one. Yeah, yeah. Because and like I say, some people without glasses are legally blind. You know what I'm
Yeah.
saying?
Oh
So
no, my eyes are pretty bad. I mean, I'm
yeah.
up on the screen, you know?
What? Oh. So now what you do to combat that?
Just be up against the screen. I just said like I had to take them off to take
I
the
tell you
test.
what, you ever use a control and you got a mouse with a wheel button on it? Even if you don't do your,
So
your
the
mouse,
laptop that I use is my mom's. It has a touch screen, so like I can be up on it and
right,
still like function. It's just like a tablet at that point, you know?
right. But because what I was saying is with the laptop, watch this phone, that's my home phone. I can hold down the control key and use my wheel button and I can increase the size. See what I'm saying?
Oh,
Right.
okay. I see
And
what you mean.
use the wheel button. So what happened, everything is brought out a little bit more where I can
Yeah.
see. Yeah. So unless they got, or you can hold down the control key and hit the plus. See?
Okay.
Or the minus. The minus takes you back and the plus opens it up.
You think that would
So
work on their thing? Because it like pops up its own little mini uh
right,
app. So I don't know if it still functions like a web browser.
right. Well,
I'll
this is
try it.
not
Yeah, I'll
right,
absolutely try it. But
right. This is and that's mostly with Windows. This is a Windows app.
yeah,
It might, yeah.
it makes you use Google Chrome specifically for
Okay,
projects.
well, it
So
might work. It might
yeah,
work. It might work. Yeah, it might
okay.
work.
I'll
Yeah,
definitely give it a shot.
right. Yeah, that's gonna help, man. Because I know straining with your eyes, and you see an E is an O, or a semicolon is a colon, and in computer science that can cause big issues.
Oh yeah.
It can cause big issues. All right. So I got the tests out there. I got the quizzes, the quiz, and then the other the read bonus. That's out there. So let's look at our next chapter. All right. So like I say, make sure y'all read up on the chapter and then take your test. Let's look at chapter 9. Now, chapter 9 deals with pointers. All right. And we'll get to understand pointers deal with memory addressing. We don't talk about it much, but when we create a variable or when we create a variable in our code, what we actually doing is allocating a space in memory to hold a value, right? So what happens is that space that's allocated has a memory address associated with it. We as programmers, we program it in a higher level. All we deal with is what? The name reference, which is the variable name, right? The computer, if you was coding in low level language, you would deal with the address. And normally low-level programming, your programs run much faster. All right. So let's look at pointers. All right. Pointers. Okay. Getting the address of a value. Okay. It's not hard. Like I say, but like I said, we're gonna run through it. The address operator, which is our ampersand. And remember, we just looked at our vector. When we passed our vector, we passed it with what? By using our ampersand so that we can get what? To the address of that vector. So now the ampersand returns the memory address of a variable, okay? Every variable is allocated a section of memory large enough to hold a value of the variable data type. So when I say it, if I say int x, somewhere in my memory on the computer, when I run that program, it says, okay, I have a variable that's of int data type. So I need 4 bytes. Okay, I need 4 bytes of free space to use for that variable called x. Okay, so anytime I'm referencing x, if I'm saying x equal 5, I'm storing that value at that address. If I'm saying x equal x plus plus, increment x 5 to 6 is going to overwrite 5 with 6 at that address. So that's what's actually happening. Now, any variable that I create as char, 1 byte of allocation. Any variable that I declare as shorts would be int, which is int. It would have 2 bytes. Any variable that has a int, a long int, or float, that long really is long int, or float would have 4 bytes. And any variable I create of double needs 8 bytes to allocate allocate the memory for that particular values to be stored, the value to be stored in. So each byte of memory has a memory address. Okay, a variable's address is the address of the first byte, okay, allocated to that variable. So if a variable, like say, is double, a double variable, it has 8 bytes. But you know your memory is broken up in bytes. So you got that first byte has an address, that second byte has an address, that third byte has an address, fourth byte, fifth byte. But the system looks at the first byte. You got what I'm saying? And then it says, okay, what's the data type? Data type is double. So it's gonna say, okay, from this point to the 8 byte, that's the value that I need when I'm referencing my double variable. Everybody understand that? Okay. Now, so this is just a short, kind of like a picture diagram. Char letter, 1 byte. The start address here, it stops here. Okay. All right. So, because what? Char, 1 byte. So it knows that all that's 1 byte. Short number. So short is of int, but it's short is 2 bytes. It starts here and it stops here. All right, 1, 2. Then we got float. All right, float int or float and int or long int would be 4 bytes, but it's float and it starts here and it ends here. All right, the 4 bytes. All right, so that's pretty much how information is actually stored in memory. It may not be stored consecutive like it is here, but it's stored in memory and it knows at the starting point and then how many bytes is used up for that particular data type. Okay. Now, the address of variables or the variables above are used just as an example. As I said, just a pictured view. That value might be anything. All right. Getting the address of a variable is accomplished by using the ampersand, okay, operator in front of the variable name. So you could have been doing this way before now. All you have to do, if I'm going to output, you just put ampersand in that variable name, and it's going to give you the address. All right. Cout ampersand amount gives you the variable of amount. All right. So it says, don't be confused with the address don't confuse the address operator with the ampersand symbol used for defining a reference variable, you know, when we actually dealing with passing values. So let's look at this. Let's go back to this. So if I said something like this, let's write, okay. Let me make this bigger so you can somewhat see. All right. And like I say, any variable that you declare. All right. So now, if I do something like int x, I'll just say x equal 5, y. All right. So I have 3 variables. Now, if I see out these variables, if I do something like see out, what I expect to get when I output this class, I should get what? Y colon, and then 5, Z colon, and then 2, and Z colon, and then 0. So let's run this. Let me do something like this. Just all right. All right, so then I'll just tab it over so you'll be able to see it. All right, so now when I run this, it's gonna give me the 5, the 2, and the 0. All right, so I get x5, y2, z0. But if I wanted to look at the address where x was, I could put an ampersand. If I wanted to know the address of where y is stored and z stored, all I need to do is put the ampersand. So now when I debug it, or actually run it, look what happens. I get an address, an address. Now let me ask you all this question. How many of you all, when you did one of your programs, when we were dealing with arrays, and you pulled the data from the file, you got something like this as a list? If you did, what happens is the computer says, okay, I don't have no value stored at this memory, this address, this array position, but what I'm gonna do, I'm gonna just give you the address. So that's what be happening. All right. So it can't put out the data. So it just say, okay, well, I'll give you the address. But we know X, Y, and Z are actually 5, 2, and 0. But this is the memory address or the location. Now, looking at these numbers. All right. Looking at this. What type number is this, class? Going back to our 192 class. What type number is this? Anybody?
Is it? It's not hex? No, it was okay.
Hexadecimal. Remember, hex is base what?
8, 9, 8.
That's octal.
Octal, hex, 6.
I
don't know, man.
Hexadecimal is base 16. Remember?
Oh, okay, yeah.
So base 16 goes from what? 0
to 15.
Which is 0. What's the
to,
value?
What is the F?
Right. Yeah, but everybody understand now, when we went over that in 192, you're looking at, F and A and E and D and C. Why is that? Look at this. 000 F E20. Hexadecimal number. Everybody understand that? So now you actually see the system giving you something in what? Hexadecimal. Everybody see that?
Yes,
So,
sir.
and I told y'all, as you work in computer science, it's gonna come a time where you're gonna see hexadecimal numbers. For whatever reason, you may not understand it, but hexadecimal is the address of is the representation of that computer's address. All right, so that's hex. Now let's go back and let's place the numbers. In order for us to place the numbers, all we got to do is something like this, and then and just say X. All right. Now we're gonna print the address, and then it's gonna tab, and then it's gonna print the value. All right, so now watch when we run it. See, X is located at this address, and it has this value stored at that address. Y is allocated at this address, and 2 is the value that's stored at that address. Z has this allocation for the address and has 0 stored at that address. So everybody see what's going on when a variable is created, right? Everybody got that?
Yes, sir.
All right, because we're gonna get into pointers. Okay, we're gonna get into pointers. So let's go back to our documentation. All right, so here, the pointer sample program, which is somewhat what we did. All right, what you have int main, int x equal 25. So what they did, see out the address of x. If we're gonna print the address of x, we have to put what in front of the variable? The ampersand. So that gave us this address. All right. Then the size of x, the size of function tells us how many bytes it allocates to store that value. All right. Because I could do that in this program. I could do something like, okay, if I could type, it's just a function that's used, /t, and then I'll say, all right, size of x. So what it's gonna do is gonna give me the size of x. So what should it print out for the size of x? Before we say that, we need to know what? Know the data type. The data type is int. What's the byte size allocated for an int variable? 4. So let's run the program. See? This the address, this the value stored at that address, and this is the amount of allocated byte size. This is the byte size, is 4. Everybody see that? All right? So that's what the size of does. Now, then it says the value. To print out the value of x, you know, we've done that many times already. We'll just print out what? See out the value or the variable, all right, x. So it's at this address at the time it was ran on whatever computer. The byte size is 4 and the value is 25. I got a question for you. When I run this program here, it gives me these addresses. If I gave this program to each one of you all, this exact same program, and told you to run it on your computer, would you get this output? Would you get this output? Hello, class? If I gave you this program to run on your computer, would you get this exact same output?
No, you would get a different memory address. In fact, if I remember correctly, each time you ran it, it gave a different memory address each time.
Depending on what's being used at whatever and what? Randomly selecting what? The memory, right? Yep. So every time you run it, and especially if you run it on a different computer, you may have a different memory address allocated for that variable, okay? So that's you gotta understand that too. that doesn't play a big part in your coding, but just for you to understand that, hey, oh, well, it should be stored at no. When you run it on another computer, your memory addresses could be totally different. Totally different. All right? Okay. Now, so here we go. Pointer variables. Okay. Pointer variables or pointers are special variables that hold a memory address. So a pointer variable can only hold a what?
An address.
Everybody, you got to remember that. A pointer variable can only hold an address. If you start writing code and you creating pointers and you trying to store data into the pointers, you're gonna have all kind of conflicts and errors or whatever, and you're gonna be confused because like, well, I created a variable, it's a variable, why can't I put it? You got to understand these rules. You got to make sure you understand what's going on, because you will run into all kind of issues. So a pointer variable can only hold a memory address. All right. So now this is another important thing. Just as int variables are designed to hold integers, pointer variables are designed to hold memory addresses. Okay. Pointer variables allow you to indirectly manipulate data stored in other variables. All right. So I could use a pointer to manipulate data, like say where X, Y, and Z was when I in this small program I created. I could create one pointer and use it to reference and manipulate the data in all three of those variables. Not all at the same time, but as I point to them and use them. All right. So memory addresses identify specific locations in a computer's memory. Because a pointer variable holds a memory address, it can be used to hold the location of some other piece of data, i.e., point to some piece of data that is stored in computer's memory. Pointer variables allow you to work with data that they point to. Now, one thing, and we're going to get to it, an integer pointer can only hold the address of an integer variable. A float pointer can only hold the address of a float pointer. All right? Well, how do I say that? A float variable. All right? A char pointer can only hold the address of a char variable. So everybody understand this. Number one, the pointer variables, all right, what we had said, holds only memory addresses. That's the first tidbit you need to know. Secondly, a pointer variable can only hold an address of its data type. If a pointer is of integer, it can only hold a address of an integer variable. All right. So let's look at this example they have in this here on this page. It says, okay, const int size equal 5. So that's going to be our size declarator. Numbers is a what? Int numbers and then size. Numbers is a what, class?
Array.
Is an array. When you see the square brackets, this is array of what? Integers. So numbers is an array, and that array has 5 elements. Now, what's happening, they're calling a function. This is a function being called, and it's called show value, and it's passing what?
The array numbers and the constant variable size.
Size. All right. So, but I want you to understand what it is really doing. No, it is passing numbers. So it's passing numbers, the entire what? Array, right?
Yes, sir.
But really what it's actually doing is passing the first position of the what? Or the starting point of the what?
The array.
Correct. Right? So it's passing that address of the array. Because remember, the name of the array is a pointer, is the address of the array. Okay? So you passing it into values. Okay? And then you're passing size into size. And then what happens? It says for int count equal to whatever. So whatever happens in this automatically gonna happen where? In numbers. Everybody got that?
We were already dealing with pointers.
Right, but yeah, right. Yep. Arrays was already pointers, correct. Right. So here we are passing the name of the array numbers and the argument size. So here it passed the address into here, and then it started and incremented until it what? Reached size, and then it finished. So it tells us the values parameter received the what? The address. So it's taking the address, and remember what we said with the address is the starting point. Now, what happens is, how does it know where the second element start? Anybody could tell me that. How does it know? Well, let's say in this case, how does the system know? Okay, I'm at the 0 position. Okay, how does it know to grab the 1? How does it know that?
I actually don't know. So.
All right, we got it.
I guess
right?
because it's sort of like a block, and it would just kind of think of it as bits. I guess like it's just literally the next one in the chain until it hits a null terminator.
Take bytes. All right, you got the byte size of what's the byte size for int? Allocation. How many bytes you need to allocate space for an int?
Shoot, I don't remember.
4, right? 4.
Yeah.
So we got our starting address, right? Numbers is our starting address, right?
Yeah.
Remember, it's a what? It's an address. Didn't it say that?
Yep.
So we have the address of where it starts. So we're going to go from that, what? 4 bytes. Because it's int.
Yeah.
You see how the system looks at that?
Mm-hmm.
It's int. I have my starting point. So I got these 4 bytes. That's the value of the first element. You got me?
Gotcha.
So when I bump up to what? Value sub 1, it says what? Oh, you moved up 1. So now I'm starting at the next 4 bytes. And grab that, and the 2 is stored there. You got me?
Yep.
Right. So, given that, let me ask you this question. If the size of my array is 5, the data type of my array is int, how many bytes I will need to allocate my array called numbers?
I mean, I would just assume to multiply, and it would be 20.
Correct. That's it. 4, 8, 12, 16, 20. Right? For each position, I need 4 bytes. And that's how it works. We'll see it in a little chart a little later on. But you understand how all this stuff come into play, and you understanding what's going on. And then when you start writing more larger program, difficult program where you got to minimize your storage, you're able to say, well, why would I use int? I could use short because all my numbers don't go beyond whatever. You got what I'm saying? So you can start writing more efficient program, right? Rather than use, this works, so I'm going to use that. No, when you start building larger programs and whatnot, you may want to crunch it down so it can run much faster, all right? So let's look at this. Numbers is an array. All right, this is the value stored in the array. When you say show val, when you call this function and you're saying you are passing numbers and size, you're actually passing the numbers array address into value, right? So you're passing the address in the values because an array name is the address, the starting address of the array, all right? Then we're going to pass the size, which is equal to 5, into this size. And then you manipulate the array by using the subscript, sub 0, sub 1, sub 2, sub 3, sub 4. All right? Okay. So it says inside the show val function, anything that is done to value a parameter It's actually done to the numbers array. Why? Because we're dealing with it at the address level. Arrays are what? Memory addresses. All right? Okay. Now, it gives us another example, but now we're doing something by reference. And I don't know, I think we did this earlier in the semester where I created no, it might not have been this class, but I could show you. But if we look at this, int jelly donut or donuts, then we say get order jelly donut. So what we're doing, we're calling a function called get order, and we passing this variable that we defined or declared in this function here. So what happens is in our get order, we saying we're gonna pass this integer variable, all right, int, and we're gonna call it donuts, but we're gonna pass it by what? Using its what?
Ampersand for reference.
Which gonna be its what?
Address.
Bam, its address. When you pass something by its address and you use it, whatever's done to that variable is automatically done in its memory location. Everybody understand that? Anytime I'm dealing with the address, right? Anything I do to that variable is automatically done to jelly donuts. See, jelly donuts is passed, right?
So you wouldn't need to return it.
Correct. There you go. Yeah, there you go. Right. I could output it here, whatever.
Would that be more efficient?
But it just depends on what I want to say, on data security and whatnot. You got what I'm saying? Sometimes you may want to pass a variable, for whatever purposes, because you only want to calculate and pass the values, use them, and not change anything here, but return maybe that, because you can only return one value. You understand? And return that value, and all your data remains the same. You got what I'm saying? But sometimes, whatever you do to this variable, you want it to change. So you may not want to do a return, right? You want it to automatically change, because you might have 3 or 4 different variables that you want to use the ampersand on, because you want them to change while you in that function. You understand?
Gotcha.
Because you only can return one value. All right, but you're right. If you do this, then you don't have to make this like int x equal get order whatever, and then down here, here do int get order int this, and do return donuts, and then have to return it here and return into x.
Suppose you wanted to return multiple variables from
Can't
a function. Can't do it?
Right. That's what I'm saying.
Even with the ampersand?
Well, with the ampersand, you don't have to return it. That's what I'm saying.
Yeah, well, okay. I see. I'm thinking about this wrong.
Right.
Okay.
Return. See, because if I do jelly donut here, and then I just pass this without this, and I do a C in donuts, when I return back to here, jelly donuts still don't have a value.
Right.
But if I do int, int whatever,
so without
and
the ampersand, it's essentially making a duplicate variable that's independent of the original. Gotcha.
Correct.
Okay.
Right. And it's going to only have the scope of what? That function.
Yeah.
That's right.
Okay.
And when you leave out, that variable, when you go back, that other variable still has its original value. Correct. Right. So you want to see an example of that? Because like I said, because I know you understand, but look, watch. If I do, like say X, or with any one of these values, and then I'll do something like, let me create something like, okay, double value. I'll say void. All right. So I'll do something like, I'm going to put comma, double value. All right. So now, if I do something like this, all right, and watch what I do here. and I'll do double value. All right. So I'll call those functions. I mean those variables. Then I'll say void. And I'll say int A, int B, int C. So all I'm doing, I'm passing A, B, and C, X, Y, and Z in the A, B, and C. All right. Now, then I could say A times equals to B times equal to C times equals 2. So all I'm doing is multiplying them times 2. All right. So now, in here, I'm going to just take this out. I'm not taking it out, but I'm going to copy this. And paste, okay. And I'll change this to a, well, okay. And I don't have to print this here, but. All right. So now, if I run this, right, all I'm doing is passing 5, 2, and 0 to A, B, and C. I'm doubling them, and then I'm printing them out, okay? Now, I could take the address off, but here we go.
You still have size of X, by the way.
Oh, yeah. Then I could just take that off altogether. So then we know the size is full. All right, so now, so if I run this, I'm gonna get what this is, 10, with that 10, 4, and 0, right? But when I return back here, I'm gonna get what? 5, 2, and 0, right?
Right.
So let's debug it. I should have put some I should have did more all right. And then I'll just do something like this. What I call it, double value. All right. So now, so let's run this. So what happened? See here? This is the information doubled. 10, 4, 0. When I return back to the main function, what? X, Y, and Z were not affected, right? I still got 5, 2, and 0. Everybody get that? But all I need to do is what? Ampersand, pass it by reference. I mean, pass it, yeah, by that address. Yeah. Ampersand, right?
Does it matter where you put the ampersand?
Huh?
Does it matter where you put it?
It can be close to that. But
well, I remember in the thing, I think it was like in front of it. I was just wondering if it was something that mattered.
Isn't it in front? Because and then I'll put it here. Here.
Oh, I see.
Yeah. And here. So now this is where they're giving it the value, right? So now, so what happened here to double? What happened? Okay, there you go. So now, whatever I do to A, B, and C, right, will be done to X, Y, and Z in that whatever I print out for A, B, and C here, X gonna be 10, B gonna Y gonna be 4, and Z gonna be 0. because what? I told it by reference, so what? That address, whatever's done at that address level, automatically does it to the in that address location. So if I debug it, see what I'm saying? 1040, 1040. You got me? I didn't have to return anything. I'm doing whatever I'm doing to it will automatically be done, you know, when I use it in that function. All right. So everybody see that dealing with the addresses, whatever I do to my variable is being done at that moment. Right. But if I take this off and just pass it by value, I'm just passing that value and not affecting any of my variables in my main function. All right. Okay. So that's that part. Now, so that's what we're talking about with Jelly Donut. Once they pass Jelly Donut, pass Jelly Donut here, somewhere up here in their protocol, they have int ampersand, and then in their function definition, they got int ampersand donut. So Jelly Donut address will be passed into the donut variable's address, and then whatever's done to donut, which means they're reading in a value, when I return back here, I'd have a value inputted for Jelly Donuts. And then I can, if I had other statements to do whatever to Jelly Donuts, it'll have that value and be able to run the program and do whatever. All right. So it says in this function, the donut parameter, all right, donuts parameter is a reference variable within this function, right? And receives the address. With that ampersand, receives the address of Jelly Donut variable. Anything that is done to the donut parameter is actually done to Jelly Donuts, because that's where it got its address from. Jelly Donut variable. Okay, so you got to understand that. Now, this is just a pictured example. Jelly Donut variable has an address, all right? So it's taking that address and it's passing it to donuts, all right? So this should be donuts in here. Passing it to donut. Oh, no, that's right. This is the call. So it's passing it to the jelly donuts to donuts. And so now whatever's done to donuts is actually done at the address of Jelly Donuts. All right. So it says when the user enter a value, the cin statement uses the donut reference variable to indirectly store the value in Jelly Donut. All right. So the connection between the two variables are automatically established with the ampersand. So there's no need to worry about finding the memory address of the Jelly Donuts variable. All right. So hopefully you're getting that and understanding it. Now, in C++, pointer variables are yet another mechanism for using memory addresses. So now we're talking about pointer variables. We know we can point to the address. Now we the pointer variables, all right? But pointer variables operate at a low level, which means machine language. This means that C++ does not automatically do as much work for you with pointer variables as they do with reference variables. In order to make a program variable reference another item in memory, it has to write. You have to write code to fetch the memory address and of that item and assign the address to the pointer variable. Right. Also, when you use a pointer variable to store a value, all right, in the memory location that the pointer references, your code has to specify that the variable should be stored in a location referenced by the pointer variable, and not in a pointer variable itself. All right, you got to understand that. So it says, as you can see, reference variables are easier to work with, but pointers are useful. Like I say, make your program much faster and even necessary for operations such as dynamic memory locations and even algorithms that manipulate arrays and strings, which we're going to see with the arrays. You're going to have a program to do with the arrays. We'll go over that once you finish your other program. So next week, we'll talk about the program itself that we'll have to do. All right. So now, how do you create a pointer variable? All you do is simply add the asterisk in front of the variable name. When you do that, it's a pointer variable. When you do that, that variable can only accept an address. What type address? Whatever the data type that it's declared to be. So it says that asterisk in front of a variable indicates that pointer, that, well, in the sense here, PTR is a pointer variable, okay? Int, okay, data type indicates that PTR can hold the address of integer variables, okay? Now, note, int does not mean that PTR is an integer variable. That means it can hold an address of an integer variable. As different. Integer variable, the value could be a number, right? Any whole number. The address of an int pointer can hold the address of an integer variable, an integer variable, which would be a hex address, right? Now, it says that note, well, we just said that. Note that this does not mean that PTR is an integer variable, but rather PTR can hold the address of an integer variable. Pointers can hold only addresses. That's very important, class. Pointers can hold only addresses. Now, you can display pointers, the address, but you could also display the value at that address. And we'll see that in a little while. Now, look at this. All this is programming style. Some people may declare a pointer by int space asterisk PTR semicolon. Some may do it int asterisk space PTR semicolon. Either way, it's right, you know. So that's all programming style. All right, so it doesn't matter. All right, so look at this small program here. This small program, in a sense, create a variable, or initialize a variable, create a pointer variable, assigns the address of that variable to that pointer variable, then it outputs the value, and then it outputs the pointer address. That's all it does. So let's look at it. So here we got int x equal 25. So the system does what? Says, okay, I have a variable, all right, and it's int. So I'm going to allocate some space in memory, all right, give it an address, and x will be the name reference, okay? I'm going to store 25 at that location, but that location has a memory address, a starting point. But how large is that memory block for x? 4 bytes. Remember, int is 4 bytes. So whatever I have in there, 25 is stored in those 4 bytes. Now, so here I have a pointer, an integer pointer that I'm declaring, all right, called PTR. So this pointer variable can only hold the address of an integer variable, okay? Only hold the address of an integer variable. Now, so what we did here, we said PTR is equal to not x, ampersand x. So when we put ampersand in front, we telling it that it's gonna take the address of x and store into PTR, which is a pointer that can only accept what? Or have stored in it an address. And an address of what data type? Int, right? And x is int, so we okay. So that's what's happening there. You have to use the ampersand. If you just would have said PRT is equal to x, you would get an error, violation. 25 would be trying to store, you're trying to store 25 in PTR. 25 is not even a memory address. 25 is the actual value at X, right? So here they outputted X, which outputted the 25. Then they outputted PTR, which PTR only holds the what? The address. Okay? So now, in short, what it's telling you, and this is just an address. It could be any other address, but this is the starting point, and from that 4 bytes. So what happened? X, which is located at this particular memory address, contains the value 25. Okay. Okay. One real benefit of pointers is that they allow you to indirectly access and modify the value, the variable being pointed to, i.e., PTR can be used to change the content of the variable X using the indirect operation asterisk. All right, so let's look at that. Look at this program here. Let me see if I can make it a little larger for you. All right, so let's look at this program here. In this program, okay, we have the same, this is basically the same information that we just looked at. Well, not necessarily, because here it's C out and asterisk PTR. So here we got int X equal 25. Okay, int PTR, which is the asterisk of pointer. Then we got PTR is equal to ampersand X. So now we've taken the address of X and storing it in PTR. But look what happens, okay? It's Cout X. Now, Cout X gonna output 25. But look what we did here. We said Cout not PTR, but asterisk PTR. The asterisk allows us to print or indirectly print, or do the indirection. It allows us to print the value at that memory location. So using the asterisk on this pointer variable, which is pointing to X, allows us to do the same thing as if we did this Cout X, right? So once we point it to that same address, we can print the value using the pointer by using the asterisk and PTR, okay? Which allows us to print out that value. But now, look what happens. If I can print out the value of the at that memory address by using the asterisk, I can even assign a value at that at that address by using the asterisk. So look what they did here. Asterisk PTR, so it means that at that location, it's equal to 100. So now what? You're saying at that memory location, assign 100 to it, okay? So now what happens is it's gonna overwrite 25 with 100. So now when I print out X, it prints 100 because I changed the value at that address, which that address is assigned to X, right? And that PTR is pointing to that address. Anybody got any questions about that? So let's look at the program right quick. So what they're saying is, I can create, I can leave that. I can create a variable. Yeah, well, I'll take it out, and then we just do just what it's doing with just the variable. All right. So what happens is, and then we'll go, because I know it's past the time. I can do something like this. Okay, I could say, oh, I got the int X. So now I could do something like this. I could say int, and I could call my pointer, as long as there's any variable valid value, and I could say PTT or whatever I want to call it. I could call it any value P or P underscore T2. It could have been that too, underscore T2. Whatever I want to call it, but that's going to be my pointer. Everybody understand that? Long as it's a what? Valid C++ variable name, right? So I'll call it that. It might be a little confusing. I'll just call it P2, pointer 2. Okay. I'll just say P2. All right. So now, then, all right, I got X equal to something. So I could say X is equal to, not X, P2 is equal to ampersand X. I have to use the ampersand because I want to store what? The address into this address. This can only hold a what? Address. So I need to put the ampersand to say take the address of X and store it there. Now I could output, and I'll just output X. All right. I'll output X. All right, so I'm gonna output X, but then I could do the C out, and I should have left it. Let's see, and what I want to say, P2, all right, and I'll do asterisk P2. All right, so now what happens here, rather than printing the address, I'm printing what? The contents at that address. So if I run this, I'm gonna just print the value twice. No, I'm gonna print, what happened? No. What happened? What it said, homework. Effective semicolon. Well, oh, I got too many curly braces. All right, I didn't clear out my function. All right, so here, we run this, and what I should get, all right, notice I got 5 here because this is the address of X, which I left in. See, this is the address, but then this is X, so that's X here. But then what? Asterisk PTR is equal to 5. So just like I could say X is, I'm gonna comment it though. X is equal to, and they use 100, all right? And that's a comment, so it's not changing it. I could say asterisk P2 is equal to 100. And I'm changing the value indirectly at X by X being pointed, P2 being pointed to X address, all right? But, okay, let me run that and show you. And what I need to do to see out again. Well, I'm gonna do a see out X, all right? I could take this here and copy it. And what you're gonna see, I never did anything to X, right? I've never done anything to X. I printed X out here, then I printed out P2. Then I use P, and X is P2 is pointing to X. But then here I said I wanted 100 to be stored at P2, and I'm gonna print out X, all right? I'll just take the address part off so it won't confuse you. All right, take that on. X. All right, so now let's run it. Oh, it's down here. So look, it printed out X. When I'm pointing to it, it printed out ampersand P2. But then right here, I said what? Asterisk P2 is equal to 100. Then I printed out what X is. X is 100 because it's pointing to X. Now, the thing is though, what I can do, I could point to X, then I'll do P2 is equal to ampersand Y, all right? Because I could point to any integer variable that I want to. Long as it's of int, I could point to it. Now, watch what happens here. What you think the value of X is gonna be when I print this out? Anybody? What would be printed out for this? Anybody? Is everybody still there?
Sorry, I was doing something. I'm trying to mess with the virtual box for Linux because it's
Oh
not
yeah.
loading.
What's gonna be printed here? We got our declarations. We pointing PT to the address of X. We printing out X. We printing out the contents at the the pointer we pointing to, which is X. But then we change P2 to equal to the address of Y, and then we saying change the address at this pointer address to 100. And then print out X. What's going to print out for X?
Wouldn't it just print out 5? You didn't really
Correct.
manipulate X.
Because I'm only manipulating what?
The
Y.
P2 pointer, yeah. Or
right.
Yeah, Y. But
yeah, because I pointed to Y and said add to the pointer. So that's how pointers can get confusing. You got to remember where you are pointing to. Because if you're not pointing to the right location, you say, man, I thought I changed or whatever. And you're like, oh, well, man, I'm pointing to this address, not this address. So it can be confusing. So I'll show you what happened. X going to still be 5. And I didn't print out Y, though. Let's see, click it in. See, X is still 5. Because even though I pointed to P2 here, well, I printed out P2. Well, I printed out X. But I made the value at the address of P2 to equal to 100. I'm pointing at this time to what? To Y. I'm working with Y address. All right. So I'll stop here. How many people still on? 6 people. I'll stop here. And any questions or whatnot? Anybody with any questions?
Like I said, I just have it for Linux.
Right. Once they finish, we could talk about Linux.
Okay.
All right. So anybody? Questions? No questions? All right. I'll see y'all on next class period. And Mr.
McDowell.
Okay. Mr. McDowell, why you ain't did my bonus?
What bonus? The
COVID
bonus?
Yeah.
I didn't even know it was posted. Like I said, I've been working because
you did say that.
we lost 3 people because they decided stealing was better.
What? No, come on, man.
Yeah, so
that's wild.
Yeah, and we were already understaffed, so I
made it harder. Yep, much harder. Yeah,
I haven't had
especially to keep the company moving at the same volume and whatever. Yeah.
Oh yeah.
Yeah.
So I haven't had time to check as much as I would like to. So it's been like a huge struggle for me.
Wow. Well, man,
my Linux grade is dropped significantly. It's like
why?
a 38 because I haven't had time to do homework.
Those assignments.
I can't even get the Ubuntu to work on the virtual box. That's how long I've been having.
What is doing?
So it gives me this issue that I tried to Google.
Right.
Or at least right now while I have time while I'm off.
Right. Did you follow those instructions that they had? I'm
trying to right now. It wants me to go into the command prompt from what it looks like and like run some kind of, I don't even know. It says sfc/scan now and that's the same thing with the thing.
But that wasn't a part of the installation though. Yeah,
here's the thing is every time I boot it, like I followed the video completely, but every time I try to boot it, it says failed to open session for the virtual machine Ubuntu. It says the virtual machine has terminated unexpectedly during startup with exit code 1, and then gives me this thing to copy and search.
Right. I tell you what, uninstall it.
Uninstall it?
Yeah, I know it might take a little time, but try to, because sometimes it's best to just start all over, because you may have missed a step or something. But I would say
I tried repairing it this morning.
Okay, what happened? Same thing.
Same thing.
Right.
So I'm running this thing now. It's some kind of scan.
Right.
Looks
Well,
like.
run that. But then what I would say to do is uninstall it. And once you uninstall it, reboot your computer. And when I say cut it off or you
Mhm.
power it off and power it back on.
Okay, you want me to unplug it too? Let the whole thing just.
Well, if you power it off, hopefully that would allow it to boot up.
Yeah.
Norm.
I turn my computer off nightly. So.
Oh, okay. And what you do is you download it. Now, did you download the right, or when I say download, choose the right option, like a 32-bit, 64-bit? Did you?
Yeah, I have a 64-bit, so I chose a 64-bit operating system, right?
Okay. And
I
your
think that's
Windows.
what the video said as well.
And you
So,
right, and you got Windows, right?
yeah. Oh,
Right.
wait, I'm supposed to have Windows in the virtual box as well?
No. Windows
Oh,
is the
yeah, I have
actual
Windows
shit.
10. Yeah, I
Right,
have
and
Windows
that's
10.
good, right? And see what because you could switch back and forth with your virtual box
Yeah.
open, right? So
And I followed the settings that
and you chose because I think they got one for Windows and one for the Mac, OS system,
Yeah, I made sure it was the Windows
right? Because
one.
it would have give you all kind of other errors if it wasn't.
Yeah,
Yeah.
that's what I figured.
Yeah. But it might be a choice you might have made or something. And like
Well,
I said,
I'm reading the error, and apparently this is something that just happens.
on occasion.
Yeah, from what I'm reading. So I'm just trying to figure it out.
Let me ask you this: do you have another laptop?
I
Like
have,
even if it's an older one, you know what I'm
yeah, I was
saying?
gonna say I do have that laptop that I take tests on and whatnot. It is slow, but if I guess if it does get the job done.
Right. And then I'm gonna have to open that stuff up for you.
It's my mom's laptop, so she's gonna be like, "What the hell is all this crap? Every time you go to school, you keep adding new stuff." I'm like, "No, Mom, I'm sorry."
Mom, buy me a new. Yeah.
Um.
Yeah.
So,
Yeah.
yeah,
Yeah.
I don't know. I'm gonna run the scan. It's like at 11% complete. I don't even know
Oh
what
yeah,
I'm
so it's
supposed to
gonna
get
take a
out
little
of.
time, and hopefully it'll fix it. Hopefully it'll fix it.
Yeah.
Yeah.
But because of the whole work thing, I've missed like 3 assignments.
Yeah, and those assignments, they're not long, but like I
Mhm.
say, you got to go through the steps. It's not it's some steps, but they're not like say it's gonna take you a whole day, but you
Yeah.
need to set aside some time where you could go through it. Cause like I said, I looked through it, make sure you did what I asked and whatnot. And like I say, when you do the one, well, you probably did the one on CoCal. Okay, yeah,
Yeah, I did do the CoCal ones.
right.
Well,
But
I didn't do the
the
previous
second,
one, the
yeah,
file
where
management.
it was dealing with that and the virtual box, right? Okay.
Yeah. Because I wasn't even able to do the first step,
Right,
right? So,
right. Now I
um,
gave you 2 papers to do too. Now
2
you
papers.
you saw those on yesterday. 2 documents.
The surveys,
No. 2 assignments.
2 assignments.
Yeah, you didn't see
Oh,
it.
I don't see it posted.
You
Wait, hold
know,
on. It's supposed to be due October something, right? No, I
right.
don't see them posted.
You don't hold up.
I'm
Let me
looking right now.
let
Yeah,
me
because I
look.
did read your email. Oh, wait, hold on. 4 popular Linux
Right,
desktop
that's one
environments
of
and Linux.
them.
There it is. It's all the way at
All
the
right,
top.
okay, all
Yeah.
right.
Don't worry.
Yeah.
It just takes me a minute.
Yeah. So yeah, I posted those assignments. Yeah.
Um, hmm. Would it be too much to ask if you would allow me to allow me to at least do the virtual box one and turn that in late? Because it's like 100 points, and these other ones are
Right.
like
All the
50
assignments, like I
points.
say, because you got to
Like my
follow
grade
step
is
by
a
step.
38 right now,
Right.
which is no bueno.
Right. So let me ask you this: which y'all one you owe me?
Let's see. So the final file management one I didn't do, but that one's 100% on me. Like I will take the mark on that. That's my fault.
Right. No, but
So
I
installing,
don't want to fail you, but
I
let me
don't want
know.
to fail either.
Right. And what I'm gonna do, I'm gonna give you a window, to have them completed. Right.
Okay.
So yeah, just let me know which ones they are or whatnot.
Okay. It's the file management Linux commands, file permissions assignment, and then the installing VirtualBox and Ubuntu on your
Oh
computer.
yeah, so those last three.
Yeah.
Yeah, okay. Yeah, those last three. File
Now, if
management.
you were to open the 50 bonus points against who am I to complain?
I'm gonna see. I'm gonna see. I
Okay,
probably.
all right.
Yeah, I'm gonna see. Yeah.
Same deal with the software and design. It's just those two previous programs and the docs. I know I'm asking for a lot, and I do
What software and design? Oh, you talking about in
for this class, the 3 and 4 assignments 3 and 4 because
Yeah, but remember I extended those for 2 days. Remember?
it's not posted yet, so I wasn't sure if. And
Yeah,
mine still says October 14th.
14, huh?
Yeah, it still says it. And I just refreshed.
You sure you refreshed it?
I just pressed the circle. I'm pretty sure.
You sure? I think you messed with it.
I am not.
Oh, wait a minute. Now, I did it. Remember what I told you? I changed the until date, but not the due date.
Until date. Okay.
That's different.
Okay. Yeah. It still says submit. Okay. Well, when you're on the module, right? It still has the little. It has the nope. You're not allowed to do it mark on it. So I wasn't.
It does.
Yeah, because it's past due. I guess. Yeah. So
I'll go ahead on and change that because I normally just change the until date so it'll keep the due date. But
gotcha. Okay.
I'll just and some student might look at it and say, oh well, it wasn't due, or not say wasn't available. But I didn't change the document on them. But I had changed them, but yeah, they should have somewhere to put the until date somewhere on there too, so that students will know.
Or at least be like maybe a different symbol from overdue.
Or color coded where it's saying it's still available.
Yeah.
I got that. Oh, I need to change that.
Also, I did want to say, it looks like someone in the chat says they'll have questions for you after.
They still online?
Yeah, they're still here. They're muted. So I wanted to let you know.
All right.
Yeah, I'll let y'all talk. Come in right after y'all.
Yeah.
Who is that?
I appreciate that.
Yeah. Who is that?
DeMarcus. I was the one that's been out for like 2 weeks for a little bit. I was in the hospital for a little minute. I was emailing you sometimes. Yeah.
You sure you emailed me?
I emailed you the last time I sent you an email. It was my excuse. I really wasn't like in contact because it was hard for me to, be on my computer. But I was like,
what you want me to do with the excuse?
I mean, I was just updating you, just letting you know, like, hey, this is my situation. You know what I'm saying? Like,
no, I don't know what you're saying.
Well, I apologize for that.
Mr. Bethel, I'm gonna be out. Such and such and such. I'll get in contact with you to make my work, whatever. But Mr. Bethel, I'm in the hospital. Okay, so all right. Now what I'm supposed to do with that?
You're right, but I won't lie to you. At the time, that was really all I could do.
Okay, all right. At least you notified me. Yeah, all right.
Yeah, and whenever I actually came back, quote unquote, to class on the 7th, but we didn't have class on the 8th.
Because it was what about fall break or something?
See, yeah, I didn't even know that. So I'm sitting in a Zoom call on the 8th, and I didn't know, we didn't have class.
Right. I started to send out something saying no class, fall break, but I say, well, normally the students when it's somewhere where the break or holiday, they not gonna come. So I didn't send nothing up. Yeah.
See, I was all out of the loop because I just wasn't like at my computer at the time, really behind on schoolwork,
Right. So we're gonna talk. Let me finish with Mr. McDowell real quick, and we'll talk.
Yes, sir.
So I set that up. I need to still go back to Linux and do that other stuff. Set that other stuff. So you're gonna be off today? And tomorrow?
Nope, just today.
Wow.
I'm back to work immediately
Okay.
until like mid next week when
Oh
your
yeah.
classes are back. So I
Yeah.
literally just have the days that we meet for your classes off. That's it.
Oh yeah. So what I'll do, I'll open this up until tomorrow morning about 12, or let's say 12 o'clock tomorrow.
Okay.
Yeah. So like I said, we could get them done and whatnot, and if in the morning you got time, you can still go back and do whatever.
Um, If I can't get Ubuntu to work on this computer and I have to go through the whole process through the laptop and say hypothetically that also doesn't work, would I be able to submit these with CoCal?
No, well, it's one of them. Yeah, the CoCal you should be able to submit, but I think it's one of them you're gonna have to do on the Ubuntu. Remember, because I want you to do the exact same thing, but I want you to do it in the Ubuntu
Yeah.
shell. Yeah.
Okay.
So it's one of them you just gonna have to do it in Ubuntu.
Gotcha.
But hopefully you could get it done. What I'm gonna do, I'm gonna change the until date on this one, so that but you should know that it's gonna be available till tomorrow.
Yeah.
Okay, so I'm gonna change that until date to today is the what? The 15th, so the 16th and 11:59 a.m. All right, so it'll be tomorrow. So copy. So just know that it's the until date. Remember.
Okay.
On this one.
Yeah.
Okay, file permission. Edit. Virtual box. Okay, so that's the one.
All right. I appreciate it. Like honestly.
Yeah, so I need to go look back at these other two. Oh no, well the other two, those papers are still due till up until next week.
Yeah.
Yeah. So yeah, those other two papers, yeah, they're still available. Like these two, they're the 21st. So yeah, you got time to do those. All right. Yeah.
All right. I
But
appreciate it.
Yeah, that should help out. Yeah. All right, have a good one, man. Don't work too hard.
I can't promise that. I really can't. All right. All right. You have a good one.
All right, you too, man. Yeah. And now who this is, Mr. What?
Mr. Stubbs.
Stubbs. What's up, Mr. Stubbs?
How
What
you
you got?
doing?
What you
Well, all I was really saying was I was a student. If you haven't noticed, I missed test one completely because I was out.
Yeah.
And I know that we have to take the test like through Chrome using Proctorio. I know you have to use a webcam for that as well, but like I said, while I was out, I missed a test, and I seen in today's lecture, we have test 2 coming up. So it may
it's
be
open now. Yeah.
yeah, so I feel like if it's gonna be too late for me to take test 1, I don't know like how you would want me to do that. I haven't
What you
even
mean it's gonna be too late?
Can I still take test 1?
Oh yeah, I'm not a stickler on. Oh well, you missed it, whatever. Because I give you 2 opportunities to take it, right? When you do have to take it. You take like when I open my test, you could take it twice. You know what I'm saying? And like I said, you don't have to take it back to back. You could take it one day, go back and study, take it again the next day, as long as it's before the deadline. Then what I do is at the end of the semester, the last week normally, or the last few days, like 2 or 3 days, I'll say, I'm going to open up all the tests and all the quizzes and give you one more opportunity to take them. If you missed them, you could take it. If you didn't, you could take it to make a better grade.
Okay.
So, right. So that's how I do it. But I could open up the test for you so that you can take test 1 now, and then like say you'll still have opportunity to take it when we do the makeup.
All right, that's fine. I really just want to be caught up like as soon as I can. But
yeah, you want to be yeah, so that when the finals come, it's like you're not pressured to say I got to make up all this. It's like my grade is good. Right. I just need to keep it. Yeah, I understand.
Because the time that I missed everything. Like before, while I was out, was whenever the first 2 programming assignments were due. So I missed the test. Both of those programming assignments, the bonus that you had posted yesterday, I didn't get the email for that until 5 o'clock. And that's when I noticed that it closed.
5 o'clock.
Yeah, and that's whenever the bonus closed. Like I pretty much missed everything in class except the Zoom calls and the first call. Actually, I was the first student for the first call, and that was like the last time I remember hearing one of your lectures.
Oh yeah.
I've been trying to catch up by rewatching your lectures that you post on your YouTube channel.
Okay, yeah.
So
okay.
I've been rewatching the second one so I can really get caught up and finish these programming assignments.
Yeah. Now, what's your name again?
DeMarcus Stubbs.
So the test.
And we need a webcam, right? Because I overheard the last.
Yeah, because it's gonna ask you all that. Yep. All right, so that's it.
This isn't a school-related question either, but through your YouTube, I see that you do Bible study.
Yeah, my brother, he is our pastor, so I got the Bible study, and he have it.
Familiar with the 7th district?
Yeah. That's our church, a part of the 7th district.
Really? Because my church is a part of the 7th district. I used
where you from?
Jennings, Louisiana.
Oh yeah, man. Yeah, man. I know that.
Yeah, so you know, like Brother Baker and all of them.
I might not know. I don't really know. Because like I say, I've been living here for so long, so I wouldn't be a part of a lot of the activities. When I was young, I used to go to a lot of associations and whatever. Right?
Oh, okay.
But our church still do it, because I'm a deacon in the church. So they know the kids still go to the 7th district and all that stuff. Yeah, whatever.
Yeah, I've been wanting to ask you that since day one.
Our church in that district. Yep, the 7th district. Yep.
Small world.
Because I think who that was, Pastor Brown, huh? He was the president for a long time, huh?
I believe so.
Yeah,
and
Brown.
Then, Pastor Gordon, I believe, was the most recent president.
Okay, yeah. See, I don't know where lately, but I know way back in the day, it was Brown, something Brown.
Yeah, I was really young. Even if I wasn't born yet, maybe.
Oh, yeah. I think he got a church in Ville Platte, I think, somewhere. Or somewhere.
Yeah, I believe so.
Lake Charles, huh? Lake Charles.
Yeah, I think, because that's where it was whenever I was smaller, like really, really young. Out there in Lake Charles. And that's down the street from Jennings.
Oh, yeah, that's right. Yep. And in Jennings, I used to play softball out there.
Really? They had a softball league back in Jennings?
Yeah. I don't know how we used to get there. We used to turn off of I-10, like the second Jennings exit. that take you in front of all the little shopping centers and whatnot.
Like the main street where you see pretty much everything. Like they got the restaurants and
yeah. You take that left off if you're coming from Lafayette, take that left off of I-10 and go back into Jennings. And I think it's like that first or second turn to the left. Right when you see that Lake Arthur exit, or they tell you Lake Arthur, go, but you take that left and you go down there, and was a baseball park back up in that community back there.
Oh, okay, I know what you're talking about. Oh, so y'all went deep in Jennings to go play. That's at the rec center.
Yeah, that's the we used to play back there. Yeah, play softball in the summertime. Yeah. Yeah, I know Jen, know some of them old boys, the older guys, because a lady from Southern, when I was looking at Southern, her name was Miss Kitty Jenkins, but she married, her name is Jenkins, but her family is from Jennings. I forgot all of I think Retail or something was her brother name, but she had about 4 or 5 brothers and stuff that played ball and whatnot.
I'm gonna have to ask my people about a little softball league back in the day.
Yeah, back in the 90s, 80s, yeah. Oh yeah. Yeah, that was a long time ago, man. Yeah. Oh yeah.
Well, I appreciate you reopening the test for me. I'm sorry I really didn't keep you updated. It was kind of like a wrong place, wrong time thing for me.
Right.
I legit couldn't see. Like
what, man?
Yeah.
But you all right now, though? Huh?
Oh yeah, I'm fine. I'm just trying to get like caught back up.
Right.
I'm the student that's like I attend UL, but I'm taking this course.
Oh yeah, I think we talked at the beginning of the semester.
Yeah.
Before it actually started. Yeah.
And I'm just trying to catch up with all my stuff. Like I have a test later on today.
Yeah.
And just trying to, get back on track. But I'm a computer science major, so it's like this is my main focus. I don't want to get too behind in programming or learning about programming.
That's right. Because like I say, we in chapter 8. We probably won't do as many chapters as we normally would do but we still need to move forward. Yeah.
That's fine. I've been keeping up with
I want y'all to understand it though. And that's why I try to take my time. I ask questions. I show examples because I want you to get it. I want you to understand it. I don't want you to be in the class and say, "Oh, I took the class. He touched on that. But I don't really know." That's kind of hard. Yeah.
Yeah, and this is a shorter class too, so it's kind of like you always have to pay attention. I've been the notes that you post, like chapter 7. I started reading those before, I stopped coming to class, and I've been reviewing chapter 7 notes, for the test. And I also found the book. Well, the free book that you had posted.
Right, that PDF. Yeah, go through that too. Yeah, because a lot of the test questions gonna come from that. And what I did, I pulled out a lot of stuff to go over so that you can understand and then do the programs too. Yeah.
Okay, well that's perfect. As soon as I get a webcam and I'll probably take the test. Since I didn't know it was like remotely proctored, I figured like it was gonna be on a set day, like we all have to go in class.
No, normally when I do my online whatever, and this is not on. It's partially online. What I do, I just tell the students, I'll give you a week to take the test. What you need to do, make sure you allow a date. Well, and then you got 2 opportunities. But make sure you set up a slot, whether it's 1 o'clock at night or 12 o'clock in the day, 5 o'clock, where you have your free time where you can just go through the test. But you can pick out the whole week what day that's going to be. You know what I'm saying? Rather than just give you a day and it's like, oh, well, I got to do this on this day. Or this, you caught up or whatnot. Yeah.
Yes, sir. I understand. Okay, well, that's perfect then. I'll prepare for the test, and then as soon as I get my webcam in, I'm going to get that out the way.
Right. Now, where you at, Lafayette?
Yes, sir.
Because, see, I think I did a survey at the beginning of the semester where like say student needs. The
Yes,
school.
and I actually missed that. I meant to do that survey. I just didn't do it because it asked like if we needed a webcam or if we
Right,
needed a
and
flash
would have happened.
drive, you know.
The school would have furnished one for you. They'd have contacted you and then try to set up a date for you to pick one up and everything like that. Yeah.
See, I don't have a BRCC email. I have mine connected through my Gmail. So
But it
like
doesn't. Oh, but you
whenever,
do have a L number with BRCC, right?
yes, sir.
So you do have a BRCC email account.
That's the thing. I contacted the school to see if I can log into like my BRCC account, well, my BRCC email,
Right.
and they're pretty much like, no, you're already connected with your personal email, so you can use that one. Which I mean is fine, but my updates come in late, like for the bonus assignment.
But what you do, and see they don't like me for that because you tell them, I'm in Mr. Sylvester's class and his assignments is posted. And, you know, he told me I need to get his assignment as soon as possible. And because by how would I say it? You paid your money. They supposed to make it happen. You got what I'm saying?
Yes,
so
sir.
What I would do, I'll call them again and ask them. Now, if they give you the runaround again, contact me and I'll shoot a letter, email, and I'll tell them I have a student with whatever, needing their BRCC account because emails have been coming late. You know, like I say, I'll do that. But just contact them and tell them, hey, I need to get my BRCC account, whatever. You know, because I think what happens is with your email set that way, you don't get no notifications through Canvas.
Barely any. I would have to, I always have to log into Canvas first.
You understand?
And then they come in late. Like,
so that's what I'm saying. So like I say, you call them again, call IT, and because I think I might have the number in the syllabus. I don't know, but you could go to the website, find the IT number, call them and tell them, I'm calling to get my email accounts set up correctly because I don't know my login or I can't log in or whatever the reason. Let them know, you know, because they got to get that fixed.
Yes, sir.
Yeah. Yeah, I got the test up for you, you know, set up for you. But you got them 2 assignments that you got to turn into along with the other 2.
The programming assignments?
Yeah.
Yes.
Right. And I want my documentation now.
Yes, and I've been I actually read that like for the correct documentation.
Right, man. Cause like I say, in one section, cover page. What's the format? Whatever format you use, but I told you what I want on it. The second page is the, when I say page, second section, you know, but which would be the second page? Because the cover page is 1 page. The second section is the statement of the problem. The statement of the problem is exactly what I give you for the assignment. Don't take nothing off, don't add nothing to it, exactly what I give you.
Yes, sir.
The output format, the variable name, all that from beginning to end, program assignment number, whatever, all that information should be for the statement of the problem. And then your source code is the next section, starting on the new page. A snapshot of your output, that's on the screen. And like I say, you could do a screen capture. Some students not too familiar with computers. They'll take a picture with their phone and then do it like that. But like I say, screen capture that. And then your header file, you know how to do the header file, right?
Yes, sir. I've been like reading along. I mean, you pretty much give us the instructions on how to do these things. You know what I'm saying?
That's right.
Like, you know, go back and read it and
back
make sure.
Go through it. That's right. Yeah. Okay. All right. And like I say, then your input file. If there's no input file, no data go there. If there's no output file, no data goes there. You know what I'm saying?
Yes, sir.
And then your data dictionary. And the data dictionary, I want all of the variables in each function listed. So your main function, all of the variables you use. The get function, all of the variables you use. Even if they're some of the same ones in the previous function, list them again. And the data type, the name, and what they use for. You know,
Yes, sir.
no long drawn explanation, just something short to the point as to what it's used for.
Okay.
Right? Yeah. Yeah. Oh, yeah. Yeah.
Oh, sweet. I'm gonna get to working on those as soon as possible and try and get those to you when I can, because kind of like how the guy before had
Yeah.
those problems, these grades.
Yeah.
These grades not cutting it. I gotta get back right.
Right. Yep. Oh yeah. Yep. All right, do my work.
I appreciate it.
Yep. All right, man.
Have a good day.
You too. Later.